Hi, so far we have met Newton's two laws of motions. The first law tells us that the inertia of an object will enable it to retain its state of motion unless and until an external force acts on it to change its state of motion. The second law basically gives us a quantitative definition of the first law by telling us that the resultant force on an object is equal to the mass of the object times the acceleration, meaning forces are in fact causes for acceleration or causes of acceleration. Alright, now it's time to meet the third law of Newton. It would be fair to say that you may have met Newton's third law unknowingly in your life. Whenever someone had said that every action has an equal and opposite reaction, that is basically the summary of what Newton's law means, but let us put that in a more contextualized picture. Whenever an object exerts a force on a second object, the second object exerts a force back with the same magnitude but opposite direction. So let's take that in for a minute. The language of objects in the universe is such that whenever two objects interact, they will interact via forces. Alright? When one object is interacting with another object by exerting a force on the second object, the second object which is being talked to or interacted with will react by exerting that same force of the same size but in the opposite direction on object 1. Alright, that is what Newton's third law tells us. So we have here object 1. The object 1 is exerting a force F on some other object 2. We call this force exerted by object 1 the action force. When object 2 feels this force F on it, it reacts by exerting a reaction force which is of the same size. So if this was of size F, this reaction force is also of size F but in the opposite direction on object 1. That is why we have the negative sign here. Alright, denotes that reaction force is in the opposite direction to the action force. So some things to notice about this Newton's third law pair are forces come in pairs, meaning one force is always counteracted with another force. Whenever you have two objects, for example, say they're touching, then one object will exert a force on the second object due to the physical contact between them, but it cannot be so that that is the only force in the problem. There will always be a reaction force from the second object as well. So that is what this means. Forces come in pairs, and we call these forces Newton's third law pair, alright, or action-reaction pair. The second consequence is that these pair forces always act on different objects. Alright, they will act if F, the action force, is acting on object 2, then negative F, the reaction force, will act on object 1. Now let's look at an example to make our understanding of Newton's third law pair more clear. Let's say this is me standing on the ground. Ground means I'm on earth, so let's say I'm in contact with the earth surface. Since we want to identify pair forces, we want to identify Newton's third law pairs, we would need to draw two separate diagrams. So to identify pair forces, we need to draw two free body diagrams for each of the objects present or interacting, because as we have just found out that the pair forces act on different objects, and so on one free body diagram you cannot draw a pair force. Alright, so let's start with my free body diagram. Let's say this is me. I have a mass, so I will have a weight, that is, I will feel the earth pulling on me with its gravitational force. Let's call this Fg, exerted on me by earth, subscript capital E, and then I'm standing on the surface of the earth, so the ground will exert a normal force on me. We call this is the same normal force that we have met in previous lectures when solving Newton's second law problems. So we can also call this as normal reaction force because it is a reaction of the earth when I stand on it. Alright, so earth exerts a normal reaction force N, let's N capital E, meaning this is the earth exerting a normal force on me. There are no other forces because I'm not moving, I'm just standing on the ground. So these are the two forces on me. Now let's draw the free body diagram for the earth that I'm standing on. So this is earth, alright. Now if you remember, I have once made this statement that any two objects with mass will attract any other object with mass by the force of gravity. Which means, since I have a mass, and of course earth has a mass, if earth attracts me with a gravitational force due to my mass, I will attract earth with a gravitational force due to earth's mass. So earth will also feel a gravitational force on it, but from me. So I will pull earth towards me. Alright, so that's why the arrow is pointed up. So this is Fg, the gravitational force I applied, Fg me on earth. And then since I'm standing on earth, that means I will exert a force which is perpendicular to the earth's surface, which we call the normal force. This is the normal force by me on the earth. Alright, so this is our free body diagrams for the two objects interacting, one for myself and the other for earth. Now let's identify the pair forces. So these are the things to look out for when you're identifying pair forces. Both of these forces need to be of the same type. Both of these forces must be acting on different objects. And both of these forces must be of equal size, that is equal magnitude, but in the opposite direction. Alright, so let's identify our pair forces from the diagram. So what are the pair forces? We have the normal reaction force from the earth on me because I'm standing on the earth. Similarly, because I'm standing on the earth, I am exerting a normal force on the earth's surface this way. One goes up, the earth exerts a force on me upwards, the normal force on me upwards, while I exert the normal force on the earth downwards. So let's check out the criteria. Both forces need to be of the same type. So both are normal contact forces, so they have the same type. Each forces must be acting on different objects. One force acts on me due to the by the earth. The normal force acts by the earth on me, and the other force acts on the earth from me. Alright, so this is also satisfied, and they must be equal and opposite. Well, they are equal and they are opposite directions. So one of the pairs is NE and N me. So the normal forces, one by earth on me and one on earth by me, they are both pair forces. Third law pairs. Now, is there any other forces that are paired? Of course, because however many forces you draw on a free body diagram, there has to be exactly the same number of pairs. So if I have two forces on my diagram, that means there are each of these normal force and gravitational force will have a pair to it, alright, acting on a different object. So of course we have gravitational force by the earth on me, and we have the gravitational force on the earth by me. So these two are pair forces because they are of the same type. They are of type gravity. They are both gravitational forces. They are both acting on different objects. One is acting on me, the other is acting on earth, and of course they are both equal and opposite. So FGE and FG me. Alright, now fun thing to think about would be, if I'm exerting the same amount of force of gravity that Earth is exerting on me, then why is it always that I am being pulled down to Earth when I am jumping, but why is it not that the Earth is coming towards me? Think about that. Let's look at another example. Two teams are engaged in a game of tug and war on Earth. So a game of tug and war basically has two teams pulling on the same rope. Let us find the pair forces on every object that is interacting in this scenario. We will start by drawing free body diagrams, as always. How many free body diagrams we have? Let's look at the number of objects interacting. We have team 1 interacting with team 2 by this rope. So any rope between two things, connecting two things, will have a tension force in it. So we have object 1, object 2 interacting via this rope. Let's consider the rope to be massless so that we don't have to draw a free body diagram for the rope itself. And then both teams are on Earth's surface. All right. So team 1. Team 1 has a mass, so this will have a weight, the force of gravity by Earth on T1, let's call it E1. So force of gravity by Earth on team 1 is denoted like that. Because it is team 1 is standing on the ground surface of the Earth, then it has a normal force exerted by the Earth on it. So let's call that N1 by E. And then let's consider friction as well, because the ground is rough. So we have a rope attached to team 1. So team 2 is this way. So team 2 will try to pull team 1 to the right. So team 1 will slide to the right, meaning that the friction will be opposing that sliding motion and it would be directed towards left. So let's call this F1 on team 1. All right. And this is exerted by the ground on team 1. And there is also a tension force which is pulling team 1. Let's call this T1. All right. Then we draw a free body diagram for team 2. Again, it will have a weight FGE2. It will also have a normal force from the Earth. So we call that N2 by Earth on team 2. Now the rope for team 2 is in this direction, and team 1 will try to pull it towards the left. So the tension force, which is a pulling force, will be directed to the left, and we call this T2. And the frictional force, because team 2 will be forced to slide in the leftward direction, the friction force F2 by ground will be directed to the right. Now let's draw a free body diagram for the Earth surface. All right. So what are the forces on Earth? Well, because Earth is exerting a gravitational force on team 1, team 1 will exert an equal gravitational force on the Earth in the opposite direction. Let's call this F of gravity by team 1 on Earth. Similarly, team 2 will also exert a gravitational force on Earth upward, FGT2. What else? We have the normal force exerted by both teams, since both teams feel the contact normal force upwards perpendicular to the ground. The ground will feel the same force perpendicular to it downwards. So let's call this N1 by team 1 on Earth, and let's call this N2 by team 2. This is confusing, so I'm going to remove the subscripts and write it as numbers beside T's, because subscript T means tension. Alright, is there anything else? Yes, because both teams feel friction from the ground will also feel friction from the teams. So let's draw a different diagram for this. This is the ground. Team 1 is sliding this way to the right and feeding the friction from the ground to the left. So team 1 will exert a frictional force on the ground to the right. So frictional force by 1 on the ground. So let's call this frictional force by T1. And similarly, since team 2 is feeling the friction to the right, it will exert a friction to the left on the ground. So F2 by T2. Now it's time to identify the pairs. We have drawn free body diagrams for all of the objects involved: team 1, team 2, Earth and the ground. Alright. Now what are the pairs? Pair forces go as the two normal forces are paired together, as we have seen from the previous example. So N1E is paired with N1T1. N1E, the normal force exerted by Earth on the team 1, is paired with N1T1, which is the normal force exerted by T1 on the ground or the Earth surface. Another pair would be N2E, the normal force exerted by team 2 by Earth, is paired with N2, the normal force exerted by team 2 on Earth. So N2 T2. Normal forces are all paired. Let's move on to the gravity. So gravitational force by Earth on team 1. So by Earth on team 1 is paired with gravitational force by team 1 on Earth. Alright. Gravitational force by Earth on team 2 is paired with gravitational force on Earth by team 2. Alright. Gravitational forces are all paired together. What else? We have the frictions left over. So the frictional force that the team feels from the ground, team 1 feels from the ground, F1G, is paired with the frictional force the ground feels from the team 1, F1T1. And then the frictional force the team 2 feels from the ground is paired with the frictional force the ground feels from T2. Now we can see that one of the pairs is left over. We haven't paired T1 with T2 or any other forces. So what can we say about these? Now remember, these two teams were engaged or locked in a game of tug of war. Alright, so none of the teams were exerting enough force to bring the other team down. Hence we can say that overall the game hasn't tilted to one side. No one's winning. At that point, that would mean that they have both teams, T1 and T2, both will exert the same amount of force on the rope. So they will both exert the same amount of pulling force on the rope, which would be the tension force. So since none of the teams are winning, that means the game is balanced, and hence T1 and T2 are equal. So they satisfy the condition of being equal in magnitude, opposite in direction, and acting on different objects, and they are also the same type of force. They are both pulling tension forces in the rope. Hence we can safely say that T1 and T2, they're a Newton's third law pair. I hope this makes sense.